In this video, we're going to complete a conversion problem, and the one I'm looking at, the worksheet, is conversion practice worksheet. And the last question says create your own conversion factor practice problem. And so you may use this as the practice problem. What I want to show specifically is how we convert units when we have either a squared or a cubed on the units. And so we're going to start by writing, and this is very important. I know I've mentioned this a few times, but this slash, whenever we're doing a conversion problem, we really need to write it as the unit that's on the top and the unit that's on the bottom. We don't want to write it as a slash getting started for a conversion problem. It just is difficult to tell which one's on the top and which one's on the bottom. So what I would like to do is go first from grams into kilograms. It does not matter if you want to change the bottom units first or the top units first. I typically change the top units. So this is kilograms. So I'm going to go to my chart. I'm going to look up kilo, and it says 1,000 base equals 1 kilo base. And I added in the word base because it just says kilo. That means that 1,000 grams is equal to 1 kilogram. So when I put this conversion factor in, I want to make sure I cross out grams. So I'm going to put the 1,000 grams on the bottom and the 1 kilogram on top. That allows me to convert from grams to kilograms. If I stopped right there, my answer would be in kilograms per centimeter cubed. But we want to change from centimeter cubed to meter cubed. So I'm not going to be concerned about the cubed. I'm just going to look up centimeters to meters. So when I look up centimeters, it's 100 centi equals 1 base. So really it's 100 centibase equals 1 base. So 100 centimeters is equal to 1 meter. I want to make sure I cross out the centimeters. Centimeters are on the bottom, so I want to make sure that centimeters are going to go on the top here. So I'm going to put 100 centimeters on the top to cross out and 1 meter. But it's very important to note, this is centimeter cubed, not centimeter. The best way that I have found to deal with either a squared or a cube is just to write in the same conversion factor equal to the units of that unit, equal to the power of that unit, So if it's centimeter cubed, then I'm going to write out centimeter, centimeter, centimeter. If it was centimeter squared, then I would put the conversion factor in twice. This allows me to go centimeter cubed to cross out with centimeter cubed. It's possible to come up with the conversion factor just so it says centimeter cubed per meter cubed. To me, that's very confusing. And if it's a squared, I just put the conversion factor in twice. If it's a cubed, I put the conversion factor in 3 times. So now my units are kilograms per meter cubed. So I'll put the answer down here. Kilograms per meter cubed. When I put this on my calculator, I put 5.19. I divide by 1,000 because the 1,000 is on the bottom. Then I multiply by 100, multiply by 100, and then multiply by 100. My answer becomes 5,190. If we are paying attention to significant figures, which we should be, there are 3 significant figures. Anytime you're using a conversion factor, those are infinite number of significant figures, so you don't even think about those. 5.19 has 3 significant figures, so my answer should have 3. So the 5, the 1, and the 9. So I move the decimal 1, 2, 3 places, and it becomes 5.19 e to the 3rd kilogram per meter cubed. Anytime we have, whether it's on the top, a squared or a cubed, or on the bottom squared or cubed, whatever conversion factor we're going to use to get rid of that unit, we're going to do it twice if it's a squared or 3 times if it's a cube. I hope this helps in understanding conversion factors with powers to the squared or cubed.